Okay, welcome back. Just another example on the topic of similarity. This time we have two triangles and it is given that they are similar. So unlike the other examples I gave, we don't want to prove, we don't want to show that they are similar because it is given that they are similar. So if they are similar, what are they asking then? They're asking us to find the length of side JK or X. They're asking us to find the measure of angle Q. They're asking us to find the side length Z. And they're asking us to find the area of triangle JKL, the smaller triangle's area, given that the area of triangle PQR, the area of the large triangle, is 189 square centimeters. So four things we need to find here, one at a time. So the first thing we're going to do, we are going to find the measure of angle Q because that's the easiest. We know that angle J must be equal to angle P, angle K must equal to angle Y, and angle L must equal to angle R. Now I forgot to mention another thing, and that is the measure of angle K is given to be 105 degrees. It's an obtuse angle. So because the corresponding angles are equal, we're going to say here that angle K is equal to angle Q because the two triangles are similar. In fact, not only angle K equals angle Q, but angle J equals angle P, angle L equals angle R, and so on and so forth. Now, because angle K is given to be 105, therefore angle Q must be 105 as well. So I'm going to say, therefore, angle Q is also 105 degrees. And that means that the measure of angle Y in degrees must be 105 degrees. That was a very easy calculation. Then I'm going to say, using this other property we learned, so that was property number one. We said that the corresponding angles are equal. So I used the first property. I found measure of angle Q. I found Y is 105 degrees. And now using the second property, I'm going to say, okay, because the two triangles are similar, one is small, one is large, but they are similar triangles, the ratio of corresponding sides are equal, and I'm going to use this property to find the other unknowns in the exercise. So I say JK over PR equals the ratio of JK over PQ. I think this was JL, right? JL over PR is the same as JK over PQ. All right. Now we just have to plug in numbers. For JL, it is given to be 34 centimeters. PR is 51 centimeters. JK is X, which we're trying to find. PQ is 21. So by a simple cross multiplication, 51X equals 21 times 34. We divide both sides by 51. And using your calculator, of course, X becomes 14 centimeters. Okay, so 14 centimeters is the value of the unknown X we were supposed to find. So we found Y, 105 degrees. We found X, 14 centimeters. Now we go after side Z. So we were supposed to find Y, we were supposed to find Z, and we're supposed to find X. Okay, in order to find Z, we're going to use the other ratio. We're going to say JL over PR is the same as KL over QR. JL is 34. I substitute the number. PR is 51 like before. KL is given to be 28. QR is actually Z, the unknown we're trying to find. Okay, we do a cross multiplication. 34Z equals 51 times 28. We divide both sides by 34, and from there, we easily calculate the value of Z. Use a calculator, you get 42 centimeters. So we found three unknowns so far, X, Y, Z. The last thing we need to find in this question is the area of the large triangle. I mean triangle PQR. No, sorry, triangle PQR. The area is given 189. We're trying to find the area of the smaller triangle JKL. And in order to do this, after using the first and second properties of similar triangles, I'm going to use the third property of similar triangles right here. And it says that the ratio of areas of two similar triangles is the square of the ratio of sides. In other words, the square of the scale factor. So I'm going to say here, I'm going to say area. So let me write it here. Area of triangle JKL divided by area of triangle PQR is equal to the ratio of sides, which was 34 over 51. This is so-called scale factor squared. Okay, that's what it is. Now, we can, of course, reduce 34 over 51. If it's a fraction that can be reduced, top and bottom are both divisible by 17, we can reduce the fraction. So that is actually 2/3 all squared, because 17 goes to 34 twice, and 17 goes into 51 3 times. So that's basically 2/3 all squared. Now, this is the ratio of the areas. So if I write here triangle JKL, meaning the area of triangle JKL, over the area of triangle PQR, which is given to be 189, right from there, I end up with a nice proportion that I can solve for the area. We know that 2/3 squared will be 4 over 9, okay? So basically 4 divided by 9 is the area we are trying to find over 189. So needless to say that if you do a cross multiplication, 4 times 189 divided by 9 would give us the answer. So 4 times 189, use the calculator, divided by 9, it gives you 84, of course. So the answer would be 84 square centimeters. So this is the fourth unknown we were supposed to find in this exercise, and we actually found it. The area of the smaller triangle JKL, which was the unknown, now it is found to be as 84 square centimeters. And we use the third property. So this was an excellent example, I should say, because we used every single property that we know about similarity of triangles. So the first, second, third properties were all used in finding the 4 unknowns in this exercise. I would call this a sample test question. Okay, have a nice day.